It's great to be here again. This is the second year for me, for the conference as well, I think. Unfortunately, I had to miss the first day of this conference, but I have an excuse, because 2 days ago, we organized the first ever GraphQL conference, and it was pretty amazing. It was completely sold out, over like 350 people attending, a lot of people attending from big tech companies and other well-known companies. And I think this is particularly exciting because it's 2016, and early 2015 was when people first started talking publicly about GraphQL. This was the first ever public talk about GraphQL at React.js conference in 2015. And it's amazing how much has happened since. This was mostly a technology used internally at Facebook. And this talk introduced both GraphQL and Relay, a JavaScript GraphQL client that Facebook had developed. And what's interesting about this is not just that it was in 2015, but also that GraphQL was introduced in the context of JavaScript. It was introduced as data fetching for React applications. Right now, it's a much broader technology. There are language implementations both on the server and on the client, dozens of them. And this is not surprising because GraphQL was not designed exclusively for JavaScript. In fact, GraphQL was first developed in 2012 at Facebook, and it was developed for the first native version of the main Facebook iOS app. Some of you may remember the previous version of this app, which was HTML5 based, and generally people thought it didn't work well. It was a bit of a mess, and during the project where they redeveloped this app, they also designed GraphQL. I'll say a little more about GraphQL on different platforms later on, but first, let's look at sort of the underlying question: why did Facebook develop GraphQL? And why are people so excited about GraphQL? And one way of looking at this is to look at some of the pain points people experience with alternative technologies, mostly various sorts of RESTful APIs. So I think these are pain points that most of us here in the audience will recognize. Let's say I'm building an app, and I'd like to display a list of GitHub repositories. So I use the GitHub API, I perform a GET request, and what do I get back? A big JSON blob. In fact, this is just getting the GitHub repositories under the Apollo Stack organization, but this is actually so much data that this movie that I made lasts a full minute. So just to get the repositories under the Apollo Stack name, I get a full minute of scrolling JSON text. And that's not all, because when I finally have that information, it may not actually contain the information that I need to show in my app. So for instance, if I want to show the names of contributors, I have to make more calls to the server. I have to perform extra round trips, and this is problematic in general. It's even more problematic on mobile because of the high latency of mobile networks, and it also means that there might be a big load on the server. So I'm not saying this to say that REST can be made performant. I don't think performance is the biggest problem REST has. But there's an underlying issue here, and that is part of the cost of making REST performant. and that is that there's a real tension, and I think most people here will recognize that tension between, on the one hand, having efficient endpoints that give clients the exact data they need, and on the other hand, keeping those endpoints manageable on the server. So there's a whole spectrum of different API designs here. Either sort of very decomposed resources or feature APIs, client-specific APIs that give clients exact data for a certain screen. The problem is that this tension occurs not just within the technologies, but also between teams. Your front-end team may actually have to ask the back-end team to develop specific APIs. They may be blocking on the back-end team delivering those endpoints. So GraphQL has seen a lot of adoption over the last year. One of the major announcements was GitHub opening up a public version of a GraphQL API they've been using internally. And what is the main idea underlying GraphQL? It's that instead of a server exposing endpoints, instead of a server deciding what data should be returned to clients when they perform a request on a specific endpoint, clients can specify their own data needs using the GraphQL query language. It's a way to specify the exact data they need against a very well-defined, typed description of the capabilities that a server exposes. And this is a very simple example. I'll show some more examples later on. But as you can see from this simple query example, it's a very readable language, and it's meant that way. So for instance, the query on the left asks for the titles of posts. It gets back a JSON response that resembles the shape of the query. It's really easy to predict what the response will look like. The response is also standard JSON. It's something clients will be able to deal with. And the query has been defined against a schema that the server provides. So it's typed, it can be type checked, validated. You can use various sorts of tooling around it. So it's a very well-defined relationship between client and server. I want to say right from the start, though, even though I started out with sort of the example of REST pain points that GraphQL has been designed to solve, it's more than that. There have been other attempts to solve pain points in REST, and I think GraphQL just hits a very particular spot that doesn't necessarily have anything to do with performance. And that's the fact that it has been designed from the start with the needs of product developers in mind. So the idea is that it's a language for front-end developers, native mobile developers, people developing application UIs. It's not a query language designed for server developers or database administrators. So one example of sort of how the developer experience of GraphQL is something that product developers really appreciate is seem to have lost my pointer here. It's a weird bug. So this is the same example query that we saw before, getting the posts of titles. You see the results on the right, but this is actually an embedded tool called GraphQL that is fairly well known in GraphQL land, and that really shows sort of how amazing this tool can be, because it offers you auto-completion, so it automatically, it helps you construct queries, it shows immediate results. If I try to access a field that doesn't exist, I get a validation error. And in this way, you can see product developers, I mean, in general, product developers get very excited when they see this tool, because for the first time, it allows them to express their data needs in their own language, instead of having to rely on backend developers. It's a language that has been carefully designed to not only describe sort of simple data needs, but also in ways that allow you to hook up to component-based UIs. I'll say a little about that later on. Just in case you're wondering, I won't really go into this, but GraphQL also has a way of performing mutations. And mutations are operations that both update state and also give you the ability to query state, so give you back results that may have been modified by that operation. So if you want to know more about the GraphQL language, there is an excellent new website, graphql.org. And actually, this is something most people miss when they first encounter this, but all the code examples are live. They have the same embedded graphical interface, which I think is kind of awesome. So let's talk a bit more about what it means to be a GraphQL client. GraphQL has been designed to be usable, and the ability to automatically update your UI, keep results consistent between queries, is an important ingredient of what makes sort of the GraphQL developer experience so awesome. An example for those of you who, and when you go to our website, dev.apollodata.com, you see code examples in different environments. So here's React Native. We have an Angular client, and I myself am particularly proud of the iOS client. That's something I've been working on for a while. It's a Swift client, and I'd like to give a short demonstration. So what I think is particularly nice about this is the way it integrates with Xcode, and it really shows how you can work with your UI components and your data declarations side by side. So it shows a Swift file for a table view controller in this case, with a query on the right that specifies the data dependencies. Those data dependencies actually come from a child component, table view cell in this case. You can see the query on the right changing automatically when I switch to a different Swift file. So it gives you a very nice integrated experience. It also has inline validation. And you get immediate feedback when a query doesn't contain the fields that you access in your Swift file, because it relies on code generation and uses query-specific result types. So it's a very nice way of getting compile time data safety. It's definitely something I think is great for iOS developers. We are bringing the same technologies to Android. There are community members working on a TypeScript target for the code generator flow as well. So let me get back here. And talk a little bit about the server side of things, because you might be wondering sort of how complicated it is to set up a GraphQL server, hook it up to your existing data sources, because that is something that I think GraphQL is also doing particularly well. It's a abstraction layer, a very thin abstraction layer over different data sources. It's not at all a sort of complete query language. It doesn't try to offer sort of arbitrary filters or selection mechanisms. It relies on application level schemas that very carefully expose data. So this is an example of a very simple GraphQL server, a part of a GraphQL server. and there isn't actually that much to it. Like I said, it's a very thin layer. This is the GraphQL JS reference implementation, by the way, that this is using together with some of the Apollo GraphQL tools that we've developed to make writing these servers easier. Servers in other languages work similarly. The idea is that you write resolver functions for fields. And by doing so, you sort of fill in the schema you've defined, and you can do arbitrary processing in sort of any field. You can also perform asynchronous operations, returning promises. So some of those operations can be performed in parallel. This allows you to hook up your GraphQL schema to sort of arbitrary data sources. One nice feature of this is actually combining data from different data sources transparently, so product developers, front-end developers don't have to know where data comes from, and they can follow relationships between very different data sources. And those back-end fetches can then go to either existing REST endpoints, databases of various kinds, external systems like Salesforce, for instance. So it's a very nice way of sort of designing a whole sort of set of capabilities that product developers can then hook into. So I want to make it absolutely clear that this is not sort of a wholesale opening up of your backend. You're not exposing any data that you would not normally expose. It's actually kind of an art to carefully design a schema to only expose things that make sense to clients in a way that makes sense to them. So for instance, you wouldn't normally expose arbitrary SQL filters, or you wouldn't normally expose sort of operations that may not be efficient enough to be used at scale by clients. But you can hide implementation details behind similar interfaces. So for instance, if you have the ability to order stories either by date with a simple database query or algorithmically, that can be a very simple filter switch for clients, but on the back end, those can result in completely different operations. So that's sort of the mantra of GraphQL: any backend, any client, any language. And I think over the last year, a lot has happened to make good on that promise. There are implementations in various languages, multiple implementations in many cases, and that goes both for client, for server environments and for client environments. There's a variety of tooling around it. So it's really turning into an ecosystem that I think a lot of future apps will be able to profit from. And when you look at this, not just from a technological point of view, but from a social point of view, we've actually found in sort of the apps we've developed internally, but also in talking to various members of the community and customers, that it sort of changes your development workflow. And we've been calling this GraphQL First. And GraphQL First relies on the fact that the schema, the GraphQL schema, is a very strong contract between front-end and back-end. So it contains type information, it can contain descriptions, it can self-document, and this empowers and unblocks product developers. They don't have to wait for back-end developers to actually implement the schema, because they can use, for instance, various mocking tools to build on mock data, to build their UI on mock data with the exact same interface that back-end developers are in parallel working on implementing. And for back-end developers, it means that they don't have to focus on writing endpoints for individual clients. They're not sort of bothered by individual requests like, this screen changed, I now need this extra field. Instead, they can focus on carefully designing a schema and exposing capabilities in an efficient way. There's another aspect that I haven't really mentioned that I think is pretty amazing. GraphQL has been designed to be to allow sort of continuous evolution of schemas. So because you always specify the exact data you need, as long as sort of existing fields are available, you can add sort of arbitrary new information, and old clients won't be affected by it. So it allows you to keep developing your schema without versioning it. You don't need a version 1 or version 2 or version 3 like you would for your REST API. And a really amazing proof of this is the Facebook schema, which hasn't actually, which is backwards compatible even after 4 years. They have literally hundreds of versions of their main iOS and Android apps talking to the same endpoint, and that endpoint still supports the Facebook app from 2012. And like for mobile development, that is pretty amazing, because this is something a lot of people struggle with. Then something you might wonder about is sort of, isn't this too dynamic? Am I not giving my front-end developers, product developers too much power? That is something a back-end developer might say, because they might have sort of carefully tuned SQL queries on their existing REST API, and they don't really know what to expect from this new interface. So one of the things we at Apollo have been working on is a way of giving you sort of insight into both usage and performance of your GraphQL server. So it keeps track of field usage. It tells you which fields are used by which clients, maybe even when you would be able to deprecate them. It can tell you when schemas are not backwards compatible, so you can adjust them. And it gives you very specific field level performance information. So if you want to check this out, we just announced this 2 days ago. There's a 14-day trial available. And with that, I would like to sort of thank everyone, the organization, and very happy to talk to people either through questions or afterwards. Thank you. Do we have? Great. Let's see. I do have stickers, but I think I left them upstairs. And this T-shirt is limited edition right now. Only people in our company have it. But we think it's pretty amazing, so we may find a way to get it to more people at some point. A Meteor question. Will Meteor 1.5 ship with Apollo? For those of you who are not familiar with Meteor, Meteor is a full-stack JavaScript framework that the company I work for, Meteor Development Group, developed. Apollo, an effort that is meant to go, it's not Meteor specific, it's something that will work with a variety of technologies. And in fact, there's no sort of special shipping or handling for Meteor necessary. It will, it does in fact work right now, and we use it in our internal Meteor applications. Does GraphQL handle subscriptions? That's a really good question. So GraphQL, the GraphQL spec currently doesn't include subscriptions, but there are various proposals that are used internally at Facebook, fairly fleshed out proposals. And actually, as part of Apollo Client, we've built an implementation of GraphQL subscriptions. So these give you the ability to deliver real-time updates over WebSockets, and a number of GraphQL backend as a service vendors and server implementers have also indicated that they'd like to implement the same subscription transport that we've implemented. So I think this is something that over the next couple of months will probably come together. Another really good question, Relay versus Apollo. What are the differences? So Relay is a GraphQL client developed at Facebook, and the reason, when Facebook first started talking about GraphQL, it was done in the context of open sourcing Relay. In fact, open sourcing Relay was one of the reasons they started talking about GraphQL. So we should be really thankful to the Relay team for making that happen. The Relay team has also experimented with a variety of design features on the client, some of which I think worked out well, others maybe not so much. They themselves have started working on a second version of Relay, Relay 2, that is in some respects more similar to Apollo. For instance, it doesn't do dynamic query construction. It does static query, supports static queries the way Apollo does. I think one of the most important differences between Relay and Apollo is that Apollo is sort of developed in the open with a lot of community contributions. Like we have over 100 contributors. We've worked with them from the start. It's also a more, I would say, modular open architecture. So it supports multiple front-end technologies. Relay supports React. We've developed Apollo client on top of Redux, which is also gives you a way of sort of looking into the inner workings of the cache. So definitely, like if you have more questions, come to me, ask them. Is it possible to integrate the client with an Ember.js app? I'm not sure actually. We have a number of Unity has developed. I know we have a Vue.js implementation, for instance. Ember, I'm not sure about. So if you're interested in it, integrations tend to be fairly thin because it's really not a very complicated interface. So for someone who has like Ember experience, maybe an app in production they'd like to work on, I think that would be an awesome open source project. When would REST be recommended over GraphQL? I think I definitely don't want to say that no one should use REST. I think for app development and mobile app development in particular, GraphQL makes a lot of sense. Like if you run into the kind of problems I described with REST, I think GraphQL is a great fit. That being said, REST is a sort of long existing open architecture with a few really nice features, like the way it integrates with HTTP and caching at that level. So if that is something you currently use, that might be a good fit. I think in general, REST probably won't soon go away on the back end. I actually think that there's, in most architectures, you'll probably end up with a GraphQL server in front of multiple backends, including REST endpoints. And especially if the traffic is sort of within data center, the kind of performance problems you see with REST for app development may not actually be that important for you. So it's definitely not sort of opposed to REST, and in some cases, REST may be a better choice.